second now. Okay. Hi, everyone. Thanks for coming to the March 2021 Gio Community Call. Our agenda today is some updates from Elias and myself, followed by two presentations, one from Pierre Curto on an implementation of Tetris in Gio, and one from Egon on how to implement graphics some interesting layout code and design code that I can't think of the right words for. So without further ado, I'm gonna let Elias do his stuff. Now I don't hear you.
What about now?
Now, yes. Okay. Now's good.
So I'm going to start sharing my screen. If anyone cannot hear me, then please speak up in the chat or in audio. Yes. So I'm still working on the compute stuff. It's getting close to the end now. It's been quite a few months, a couple of months to implement this, and as I spoke about it last time, for those that do not know about the new renderer in Gio, it's a replacement for the existing one that is more featureful and can support more drawing primitives natively, such as third order curves and strokes, and is much easier to extend in the future with more complex drawing primitives and more types of materials and so on. But I'm mostly working on replacing the existing renderer and making sure that the replacement is as good as and as performant as the existing one before we can switch to default. Yeah. So the status is that it still, like the last time, it works on Linux and Android, and that's mostly because for Mac and iPhone and the other platforms, you need Metal and Direct3D support, which is not that difficult to do. But the most important thing for me is to make it, as I said, performant and worthy of being a replacement for the other renderer. Since last time, I've got the CPU fallback for devices that do not support compute to work for ARM64, which means that phones, Android phones in particular, that do not support it, older phones or less phones with lower specifications can run the new renderer. It's still not optimized. It still doesn't cache the rendering, so it's not very quick, and it's not upstreamed yet for that reason. But it will at some point be able to run the low-end devices will at some point be able to run this new renderer. So I've since plumbed through the third order curves drawing. So if you have a path and you draw, you use the cubic call, it's now instead of being replaced with a series of quadratic or second order curves, it's now passed directly through to the renderer. And secondly, simple strokes, that is strokes where you don't change the default caps and joins and don't use meters or dashes, are rendered by the compute shader. So they're very efficient. I also sneaked in a change of the default so that if you just use the strokes in Gio, you will get the fast ones without fallbacks, which is the one with round caps and joins. And very soon I think that at this point the renderer is feature complete, and it does work on all the interesting platforms where I want CPU fallback. So I expect to make the compute renderer the default renderer soon, at least the one for the devices and platforms where there is hardware support. So please do test your programs for whether your program does work on with this new renderer, and you can use this environment variable to force the use of that of the new renderer. So it's still not performant yet. I haven't done that much in the performance area. I've done a few of the low-hanging fruits. For example, avoiding an expensive re-encode from the old format of the old renderer to the new renderer, but mostly the things that takes a long time in the new renderer is not fixed yet. So you can't you don't expect yet that the performance is up to par with the old renderer, but it should visually be the same result as the old renderer. And I still also need to do 32-bit ARM for the very low-end spec Android devices, but I don't expect to have many problems with that because Swift Shader, which is what does the heavy lifting of compiling for the CPUs, has support for ARM 32-bit, and it does work already for ARM. I have confirmed support for ARM 64 and, of course, AMD 64. And as the last time, I still need to do Windows and the Apple platform support. So if you do have any leftover time or interest to do the Direct 3D or Metal support, please let me know. So a little bit longer term, the new renderer is faster and has many other great features. But one of the things that I also like is that it opens up support for more complex primitives being done on the GPU instead of having relatively slow fallback code to convert them to something that can be rendered natively. And right now it's the simple strokes, as I said, but I would like to, in the longer term, to have all the stroke styles being supported. For example, the ones with dashes or different line caps and so on. I'd also like to see gradients in, and I think I saw a comment on the upstream project, piet-gpu, that RAF is interested in, or at least thinking about implementing gradient support. And of course, drop shadows, which I think is one of the big things that we're missing in the current renderer model, would also be nice to do. I do not have immediate plans to do this because I've already spent quite a lot of time on the renderer, so I need to handle some of the other high priority things in queue. But if you do have any interest or time to do it, please let me know so I can point you in the right direction. And again, the issues, the thorny issues, is the same as the last time. We can't really replace the old renderer completely until at least we have browser support. And browser support needs either WebGPU, which is an upcoming standard for, among other things, compute rendering, compute shaders in browsers. So the old renderer will be there for some time yet. And of course, there's an issue with having CKO running on Windows because, at least for now, TU does not require a C compiler, a native C compiler and toolchain on Windows. So that's it. Thank you very much.
Okay. Thank you. Does anyone have questions on that before we move on? Either out loud or in the chat. Okay. Well, briefly, I have been working in the last month on implementing some new material design components for the GUI.org/x/component package. So I'm going to try to show you one of those briefly. Can anyone see this?
Yes.
Okay. So I've been working on right-click kind of context menu style widgets because it's something that I need a lot. So it's really a set of abstractions. There's a context area abstraction that you can overlay on any other widget with a layout.stack, and it will contextually display some other widget function when it's right-clicked. So you combine that with a dedicated kind of menu type that lays out, a material surface and a sequence of other widgets in here. And I provide some kind of helpers that generate properly formatted elements for in here. So you can put anything in here. You know, I've just shoved a plain label. I've shoved a loader in here, but you also have interactive elements so that you can make stuff happen. And they work in layout.lists as well. Oh, and they support icons and hint text and that sort of thing. Now this is a nested scrollable, so I actually can't scroll through this list, but that should be fixed soon. But yeah, so I want to give a quick shout out to Egon for helping me. I was trying to figure out drop shadows, and while we don't have radial gradients and we don't even have gradients on the compute side, there is a gradient-ish thing that Egon came up with under here that simulates one using 3 translucent rectangles instead. And I guess that's what we're going to be working with until we can get good gradient support in the compute renderer. So I would love it if somebody could work on that. I'm probably not the person. I'm gonna try and look at it again. Elias gave me some pointers earlier today, but it's pretty far outside of what I've done before. So if anyone else is like super jazzed about implementing gradient support, please talk to me. That is the big update from my side.
Yeah, so regarding the compute support for gradients, what I mentioned to you is that there's actually several parts of the compute renderer. There's the bulk and the difficult to understand, at least for my part, which is the upstream piet-gpu project, which it handles all the difficult things, which is generating, taking curves and then generating shapes for that. But since gradients is simply just filling for those shapes, so it can be done at least in the way Gio does. There's 3 parts: the part where you upload the images, so textures or just plain old Go images as a texture to the GPU, and then there's a section that transforms those images. If you have let's say if you have an image which is rectangular and then you rotate it, it has a process where it draws the images with the transformation that you have applied. That's the second step. And then the third step is taking the piet-gpu and rendering curves and applying the materials such as images on top of them. So gradients and probably also drop shadows can be done in one of the 2 first stages, which is not as difficult or as complicated to understand as the last step. So it will waste, I think Egon brought up this point, it will waste some texture memory, but at least there's support, at least you have some kind of support. And if you do it in the middle stage, which is where the GPU draws, you're using a relatively simple fragment shader to draw the transform material, then it can also be very, very performant. Still wasting some texture memory, but it can be as performant as you would expect from a native support.
Anthony asked in chat whether we've thought any more about the gradient API. In particular, in Slack a while back, we were discussing the radial gradient API, and Anthony pointed out that all of our prior work assumed that the stops for where the gradient colors originated were at the center of whatever circle or ellipse that you were working with, but the way SVG models it is different. I haven't talked about that or tried to iterate on that idea. Since then, I agree that maybe matching the SVG semantics would be easy and helpful, as a familiar gradient primitive. That's all I've got.
Can someone remind me what exactly this SVG semantics are?
So for a radial gradient in SVG, you define an ellipse and then you define at kind of an arbitrary point within the ellipse where the kind of origination of a color is. So it can be, if it's a circle and you put it off center, you can get that kind of light on a sphere looking effect where it's concentrated in like one edge. Anthony had a good example image for it in Slack.
So it sounds to me that some of the transformations of a gradient can be represented with a transform. Is that correct?
It's not quite that easy, but they are similarly kind of simple kind of code how to kind of produce them. The one issue we might hit is that what happens if we have like 8 different gradient types and kind of that thing.
Yeah.
The other issue with those gradient variations is that how do you define the stops? So there's one aspect is like how do you get multiple stops into the GPU first of all? Like if you have like 100 stops, how do you kind of pass that along? The other is you may not necessarily want to use RGB color space for the gradients always. So that means kind of either building in support for different color lerping algorithms, or I think the better approach for those is to pass in texture, 1D texture for the gradient, because like doing all of that on GPU would kind of, I think there's like 10 or more different like ways to interpolate between colors. Right? Yeah.
So I guess the answer is there have been no decisions made about that.
But about presenting the stops to the GPU, it shouldn't be that difficult, unless I misunderstood you, because we can write a fragment shader that does just gradients, so it can take whatever data it wants.
Oh, sure.
So if you look at the compute Go, there's a function call for images, to uploading images, one for drawing materials, which is where you transform them, and then the last step is, as I said, the actual piet-gpu execution. So I suppose that somewhere in between you can have rendered gradients and take all the operations that do gradients and batch them and send them as vertex data to a specialized vertex and fragment program.
Yeah. So yeah, the main issue with, so I spoke about kind of passing the gradient as a texture. One of the issues is like when you're, let's say the gradient is like 8,000 by 8,000 pixels, and then you want to have like 2 stops at like 700 and 705 pixels, like. So you get, let's say, a radial kind of circle gradient. So kind of, basically it needs to do some lookup and kind of stuff.
But you can't do the computations in the fragment shader?
You can, but you just need to pass in varying number of stops to the shader.
Okay, varying number of stops. Okay, I see.
Yeah. But you can...
And that's where the 1D texture comes in. I see now.
Yeah,
okay.
yeah.
Yes. And we can do that. I think 1D textures is you probably know better than I. It's probably a common way to pass variable number of data to.
Yeah.
Okay.
And of course, for common paths like 2 stops or 3 stops, it might make sense to hard code those versions. Yeah.
I got disconnected there. Can you hear me okay?
Yes.
Okay. So I think yeah. real quick, Lucas asked if there's any plan for blurring or whether piet-gpu already supports that.
That's the double no.
Okay. And I think that we're going to reorder our presentations today because Egon needs to leave earlier. So Egon, why don't you take it away?
Sure. Where's this? So I was thinking about what to talk about, and I thought about this might be an interesting topic: how to kind of write different editors for like visual manipulation things. This is largely based on this article. I read it a while ago and tried it, and it's a pretty nice way to structure things. So what's the main issue with the editors? One of the issues is that you kind of need to display tons of information. You need to display the grid, you need to render the objects, you need to kind of show the selection around an object and maybe some rulers at the corners and kind of all that meshes together really nicely. Of course, you also need to kind of control these things like zooming in, panning, like different keyboard shortcuts and maybe pen input or something. And one of the issues that is that, of course, you kind of these accumulate the more complicated the UI gets, the more kind of problematic it becomes. So like the naive solution, what's usually done is that you have a shape and then you have a field on, oh, this is selected now, and then there's a method to draw the selection around it, and there's a method to draw the handles for an object. Of course, this doesn't scale as neatly as we would like to. And our article proposes different solutions. Effectively, you have different layers stacked on top of each other, each responsible for different parts of the UI. So in this case, taking a simplified view of this Inkscape example, is that on the base layer, you have the drawing of the background, then the next layer draws the rulers, and then you have a layer that draws shapes. And of course, then you have another layer for drawing handles, and finally something that draws the selection. So this separates out these different layers in a nice, neat way. And of course, what you can do then is, instead of, because you also need to support tools, and what you can do is disable and enable different layers to get the different behaviors. For example, if you want to do freehand drawing, you cannot select at the same time, so you may need to disable this selection handling. Of course, you can kind of combine and kind of make them interdependent in different ways. So you one layer might modify options on another, and you also can hook this enabling, disabling into the UI. So yeah, and when you're drawing, of course, you need to grab the exclusive input. So if you're drawing a line, you don't accidentally want to start rescaling an object. So there's a need for that as well. And like this is the core idea, and I can then show the demonstration of this, and the code is available here. But this was kind of when this one was written like 9 years ago, when I was just exploring this idea, and I decided to rewrite it using Gio. So I'll show that program. I guess there was already a GIF in the Slack. However, like this shows, I have added a few more things to it. So as you can see, I'm actually only using my mouse. So I'm kind of when I'm start dragging on the background, it draws this box. When I start drawing from this port here, it will start making a new connection, and I can kind of move them around. Of course, I can control these different behaviors or different styles for them. And on the left side, I also have all of these different layers that I talked about as a way to disable. So I can disable drawing these nodes. However, like that's probably not the useful thing to do. However, there's like this zooming of things that I can disable, or let's say I don't want to accidentally create new connections, then I can disable this connection creation thing, and I cannot create these connections anymore. And if I re-enable, then it like comes back. And yeah, this is the demonstration. And how it ends up looking in the code. I have this basic structure for diagrams. It keeps track of the nodes and connections, and it also has this set of selected items as well. However, this doesn't necessarily need to be in the diagram structure. So this is like one way to implement all of this. You of course need to modify it for your own needs as things go. But yeah, the data structure itself here is pretty much you have a box, which means that it has a position and size. It has some styling, and it has different ports where you can connect things. Ports themselves are just something that's being owned by somebody and offset on the relative to the owner. And connections are connections between different ports. So this is the data structure that the whole editor starts now modifying. Of course, you can see that here there's no kind of special method to draw the selection border around the node. So that's somewhere else. So the main core of the system is kind of this HUD manager, which keeps track of the diagram, the current zoom level, and maybe offset as well, and the different HUDs that it is able to display. So I also added this Boolean to disable them and enable them. These, of course, can be differently implemented as needed. So you could do the Gio approach of kind of manually calling each of those items and calling the layout on those. Or in this case, I put them into a slice and then loop over them. And so here's some. So these are the parts that render the different control panels on the left and right. But the core of the HUD manager or the HUD managing is pretty much this loop here, which kind of just skips things that aren't visible. And if some layer has decided to grab the exclusive input, then for every other layout, the context has been disabled. Now, to make it more convenient to pass around this, like the theme and zoom and all of these pre-calculated data, I've created my own custom context type just to make it more convenient. It kind of contains mainly like links to the actual context and theme and things I always need to pass around. And of course, it has the transformation to handle this zooming. So like here, as I change the zoom, this context gets created with a different transform. And we can take a look at, let's say, this layer for drawing nodes. And this is pretty much it. You iterate through all the nodes and then you draw it. So nothing, no special magic here. Drawing connections is pretty much similar. There's just a little bit more to draw outlines on a path. And yeah. And one thing I did with the different ports for the nodes is I decided to make them contextual. So if nothing is selected, they are not being drawn, and it's only being drawn for things that are selected. And if you start drawing a new port, then like all of them become visible. So you can make different systems interact. So this port rendering doesn't know anything about drawing connections. However, it does have this link to enabling this port drawing. I have some layer to draw the grid and what else? And of course, like manipulation, so tracking and moving nodes is the usual drag drop thing for Kia. A lot of logic. However, like it doesn't really, well, manipulation HUD here does currently draw things. So the focus draws the outline for focused items. But yeah, so, and what else might be interesting to show here is, so for creating a node, while you're tracking, it ends, when you start tracking, it ends up grabbing the exclusive context, and then it will draw the temporary box until it's ready, and then it puts into the diagram. And the same for the connections. And yeah, I think that's pretty much it for this program. And if you end up building something like this, it might help as one way to approach this problem.
That's super cool. And I'm really glad that you pointed out the fact that separating the layers that way lets you separate concerns in a way that scales better as the UI gets more complex. Yeah, I definitely would have done the naive thing if I was implementing it. Any questions for Egon while we still have him?
Yeah, maybe a little question. Do you envision to port the zooming and the viewport thing that you embedded into your own context into something that could be put into Gio proper or Gio extra?
I think some
really,
sort of...
Or was it really tailored at your use case?
Currently, it has been tailored to my use case because, like, the zooming and panning thing, like, it's like it could be useful. However, I'm not quite sure how much use other people get out of it. Like, I can imagine that it could be useful to do it. However, I don't think it would be too complicated to do it on your own either.
There's a really, really lightweight implementation of just zooming in the Galaxy demo, but it's not very many lines. I also kind of struggled to figure out what part of it would be useful to extract into a general purpose type, because the exact behaviors you want are kind of context dependent. Do you want to, like, which kinds of clicks are gonna actually initiate the actions, and which do you want to preserve the scale of the axes relative to each other? And there's probably some kind of general purpose abstraction with a bunch of flags for which of these behaviors it uses, but it was not obvious how to build.
Yeah, you don't see me, but I'm nodding when
Any other questions? Okay, well, thanks a bunch, Egon. I guess we'll transition to Pierre's presentation.
Yeah, thank you. Can you hear me well?
Yes.
All right, perfect. So let's start. I'm going to share my screen. Okay.
Looking good.
Yeah. Okay. So my talk today is about a little game that I built over the last couple of weeks. It's basically a clone of Tetris, which I called Blocks, and it's fairly simple, but it's very fun to play. So it's completely built out of the Gio library. There's nothing else besides it. So no Ibiton, which is more sort of a dedicated framework for games in Go. I wanted it to be completely independent except for Gio, just as an experiment. Why did I made it? Well, first of all, to see what could be done with Gio, especially since it's an immediate mode system. So I decided to go for Tetris because it's quite a simple game. And it was also a way to explore some of the parts of Gio that I hadn't had a chance to actually look at or use. And of course, to actually entertain my kids and myself, because we built the game together. They were responsible for the textures and the overall ID and of the screens, and I was responsible for everything else. So that's quite a fun project. Fun project, but quite a few challenges because it's the first time I actually wrote a game. So I had to think about a couple of things. In no particular order, a lot of state management, either for the screens that you need to navigate through before you can actually play. Of course, the game itself, with the score, with the next block, with the current set of the blocks, etc. And how actually going about displaying them, because of course this has to be very graphical. And then how to actually update the game on a regular basis so that you can get the next block, or you can have the current block move automatically to the bottom of the screen. And then finally, I wanted it to be a bit bit nicer than just when there's a new set of lines that is that occur, then making sure that we can visually see those lines being removed, as well as a couple of other animations that I wanted to have. So first time I was actually using GIO to produce animations, so it was quite interesting as well. So I'm going to go through some of these. And first of all, how did I go about building the game? So of course, typical process is to break it into manageable parts, so parts that you can actually solve individually. So I started with a grid. So basically the basis for the game, the Tetris game is basically a 10 by 20 grid. And then on top of it, I actually apply various textures in order to represent the blocks and the blocks that are currently moving and the ones that have been already placed on the grid. And then there's the blocks themselves. So how to actually define them. And then also how to rotate them. That was also an interesting part. So the block can be rotated by the user. And obviously, I want that to be as simple as possible in terms of handling in the code, and I'll show you how I did it. And then user interaction. So it's only by a keyboard. So you have special keys assigned to block rotation, left or right, or also moving the block left or right. Also what is called soft or hard drops. So soft drop is basically telling the block to go down line by line. And then the hard drop is telling the block to just go down as much as it can, as far as it can. And then an interesting piece was also collision detection. So making sure that whenever the user tries to rotate a block, make sure he can, because it could be hitting the side walls of the grid, or it could be hitting another block. And then of course line detection, so making sure that when the line is complete, that it gets removed from the screen. Otherwise the game is over pretty quickly. And then everything else is just the cherry on the cake. So basically having a set of screens to navigate through before getting to the game in order to set the speed at which the blocks arrive. Define when the user wants to start, being able to change the keyboard maps, also the textures, something I added at the end. And of course, since it's quite a competitive game, making sure people can actually fight over the scores. So how was it done? So the first of all, I'm going to look at the grid. So grid, as I said, is a 10 by 20 grid. So 10 cells width and then 20 high. I added a couple more, as you can see visualized here in blue. It's basically invisible balls. They are not displayed. This is for collision detection. It just makes it much easier to actually detect collision when the block needs to be moved, either because it's going down or because the user is rotating it. It's very easy to detect whether you're out of the grid or not through this method. It's probably not the only method, but I found that it was the simplest. And then also the green one at the top is something I added later on after playing a few times, because when the block appears at the top of the screen, it appears right at the top here. And then by default, you were not able to actually rotate it, which is quite challenging when you have a pretty full grid and you try to shove it into a smaller space. So I just added that to be more enjoyable when playing it. Special note on this texture. So each cell of this grid can display a different texture. There are special ones. The blue ones are basically invisible, what I call invisible textures. So they are physically, let's say, visible for the collision engine, the collision detection, but are invisible to the user. And then there's the transparent ones, which is basically everything else. So when there's nothing there, it's just transparent. It displays the background. And then, of course, there are the textures for the blocks themselves, which I'll show you later on. That's for the grid. So that's setting the scene for the game. And then what do we do in the game? Well, we move blocks. So there are actually, in Tetris, there are 7 of them. They are all named about the letter that they represent. So there's the I, J, L, etc. It's quite a common nomenclature. And each of those can actually move around. They have some degree of freedom. So when you actually when I define the block, I define it like this so that you can rotate it. Actually, I forgot to put the rotation that each piece can do. So the eye, for instance, by default, it comes horizontal. When you rotate it, it's actually displayed here. It rotates from this cell here in order to get a vertical eye. And the same for the other one. So each one of them has a specific point of rotation. Of course, this one doesn't have any because it's completely symmetric. But then it defines how the block can rotate and what they look like. So when the user presses either the left or the right key to rotate, then I actually change the way the block is drawn on the grid by looking at it from different angle in terms of coordinates. So if it rotates towards the right, it's actually like looking at the block from the bottom here and the bottom left, etc. So if it rotates to the left, it's actually looking at it from the top right. So that allows me to actually define the blocks only once with a set of slices. And then depending on the rotation state, then I can draw the block accordingly. So it makes it easier in terms of defining all the various blocks and not having to define, 2 or 4 times number of blocks in the code. So there's only 7 of them displayed, and then the block object that handles drawing the blocks on the grid that does the rotation on the fly. The blocks are actually chosen randomly. It's not perfect because sometimes you get the same set of blocks, which can be quite difficult, especially if you get the S or the Zs. But that's one area for improvement, is to make sure you don't always get the same. Maybe limit the number of times you get the same. There are different algorithms that I looked at, but in the end, I just studied to keep it random just for simplicity. And then obviously, as a new block needs to come into the play, then it gets sent to the game by the main GIO event loop. So on top of actually the frame event loop, there is a ticker which decides when a new block needs to be sent to the grid. I'll show you that in the code. So that was fun. Another fun part was dealing with animations. So basically, I wanted to have 3 kinds of animations. One is in the title, you will see in the game, I wanted to reflect, visually the level that you select, and the level basically affects the speed at which the blocks go down. So I wanted to show that. So I have an animation on the main screen or the home screen, which shows that. It's quite nice. And obviously, since it's a competitive game, when some special events occur, like you make 10,000 points or you reach a new level, then I'm actually flashing the scores or the level so that the user has a visual cue that he's achieved something. Then of course there is the lines. When the lines get completed, I wanted that to be visually visible. Visually visible, yes, quite a but I wanted it to animate somehow. So I've got a simple animation to reflect the lines that have been completed. And for this, actually, sort of abstracted out into a dedicated object. I will go through the layouts of the packages. It's pretty straightforward. But in the widgets package, there is an anim object which takes care of the animations. Very simple. You start an animation through the start method. You basically say this is the start value, the end value that you want, and then you specify a function that says how to go from one value to the next and how long it should take. And then from there on, the anim object takes care of it. So making sure it sends an invalidate operation to the main window so that it gets animated properly. It checks that if it gets a frame, but it's still not ready to go to the next one, it doesn't change anything, etc. And then a couple of other methods useful when you're dealing with various types of animations. Sometimes you don't want to actually animate, whenever it's ready. You may have several parts of the GUI that needs to be aware of the current value, especially in the score, because I'm animating the label as well as the value in the score. So I just want to make sure they are synchronized. And then, of course, is the animation running. And then finally, less interesting, but still very useful, is actually keeping track of the state So where you are in your application, so there's kind of 4 main areas. There is the home screen where you can set the level and change the settings and get access to all the various options. There's the game itself. There is the settings where you can change the keyboard mapping and the textures for the blocks. And of course, the scoreboard where you can see your achievements. So I have a very simple state engine. It's very simple. Each of those are represented by a dedicated object, dedicated structure with their own state. And then the home object, the UI object, manages some of those substates because it needs to know when the game is over, for instance, so that it can decide to go back to the main screen or maybe show the scoreboard and ask for the user for his name if his score is high enough and gets into the board. So that's about it for the slides. I'm going to show you the game itself. For this, I actually wanted it to be full screen, so I implemented the full screen feature, which was merged by Elias a couple of days ago. Because when I start the game, it goes into full screen. I hope you can see it. And in there you see, so this is the animation I was talking about. So the O letter is actually moving down at the speed which is selected by the level. It flashes a little before actually going up and then down. So if I change it to the last level, you should see at the next iteration that it goes quite faster. So that's easy to see how fast it goes based on the level. So this is the menu where you can start the game. We'll start in a moment. The scoreboard, the settings. So the settings is where you can define your key mappings. So if I want to rotate left with different letter, you click on it and you select the letter that you want to use. The pose, oh yeah, I'm using a different font as well. So this is why some of the keys are not showing up properly. This is the escape key. And you can also select the texture. So there are 2 parts, color. So you can change the color of your block and also the pattern. So there is just no pattern. So it would look like this in yellow. You could have this, you could have that. So you change it to your liking. I like this one in particular, but you can also have this or very basic gradient, which is quite nice as well, I think. But I like this one better, so I'll stick to this one. So when you start a game, you get the grid. So this is the grid in here. And this is the scores with the current level. So I'm starting at level 4. This is the next block. So I can rotate the game and I'll show you when a new line is complete. Hopefully, doesn't take too long. So a small animation to indicate that the line is complete, etc. You can pause the game by hitting the S key. So you can decide to continue on or to actually leave the game. What I'll do is I just quickly end the game, in which case, of course, it's over. And then I have the best score in here. So I can say, this is me with my current score. And if I want to go back to it, I just go in here. And then when you leave the game, everything is saved. So if I restart the game, instead of having the red blocks, I will get the yellow ones, or not. Okay. And okay, this is a bug. It used to work. Okay. Well, it should have saved the textures and also the board, etc. But obviously, there's an issue with it. So I'll fix that. So that's the game itself. So how was it actually built? I'll show you briefly. So the command here for the actual binary, that is very simple. And then there are let's say, two main packages: the UI package, which is basically the core of the game, and an extra package for some widgets. So we're showing about the animation in here. So you see, it's quite simple, but this piece here is the thing I didn't want to deal with every time I wanted an animation. So I decided to put it into a dedicated object. There's a couple of other things like the menu, for instance, where I'm always displaying items in a single column at the center of the screen. So I have, and actually allows me to tinker with a few APIs. So it's very similar to the list API, except that I have this menu element in here, and that is referenced by index. So I can define my various elements I need to display, and I have different kinds of them. So there's like a spacer to put space between the items I want to display. There's a button, that's the button to start a game or quit the game. There's the title. Well, sorry, an item with a title or no title. So when you were looking at, for instance, the scoreboard, we're indicating scoreboard, and that's the title. Sometimes I don't need a title, so I also have this this element. So that's for the widgets package. There's also a small version one to manage the current release of the game. So do go generate in there, and it generates the text files for the version that is displayed at the bottom of the screen. I don't know if you noticed, but the version is displayed at the bottom of the home screen. And then the core is here. So there is the UI, object where you set there's a dedicated theme with different colors for various areas of the game. And also you can see the various structures for each page of the game. So the home screen, the scoreboard, etc. And then very standard stuff where manage the layout. You can go directly there. The layout is based on the state. So depending on the current state, I display this or that page, and the state can be changed through the changes here. So if it's in a home, it checks that the game has started, or the user hit the scoreboard, etc. The game itself, well, the game itself is based on a grid. So just show you the grid quickly. So very simple. You define the grid. So you initialize with the cell size that you want. It's actually fully dynamic. So if it's not started in full screen, which I can actually do quickly here, you can resize the window, and it will resize accordingly. The only thing that doesn't resize is the score. So you know, the score doesn't look nice, but the grid itself gets, I don't know why it's so flickery, but resizes. What else? And then there's layout. So the grid is really just a big slice of textures, and the texture is very simple. Define the basic default textures in here. So by color. Also the special ones I mentioned, transparent and invisible. There's also the patterns. So the various ones in here that we saw. There's also maybe not optimal, but decided to have one per gradient depending on the rotation. So when the block rotates, you want the gradient textures to rotate, otherwise it doesn't look nice. So this is to handle that. I also have, it's not enabled, but image textures. So the kids made their own textures so that they can play with their own you know, look and feel. So this is, I extracted that out of the package that I've published, but basically you can define your images in here, and it will pick them up through the embed, actually through the embed, the new embed directive that is available in Go 1.16. So this can only work on Go 1.16. And then you can make use of that to when you define your blocks, or in the settings where you can display your images and select the ones you want to actually use. So the blocks themselves, so the I, J, L, etc. So simply defined in terms of texture and size. So just as a hint for the block item that displays them to know what to do. And then the game itself, of course. So the game is the most complex one. It's got various states as well, and a few methods to determine what to do and handle the various updates. So making sure that there's no full line. So if there is one, then start the animation. Otherwise, just do nothing. What else? So the animation is in here. So when it's running, and then when it's actually complete, then it removes the lines that have been completed. There's also the update method here. That method basically is either called when there is a new block that comes in. So from the main loop, it calls the update method. So the main loop is calling it from here when you start the application. So you see this is the main GIO loop for the frame events. And then here it looks, it requests the game to tell it if there is a new block. If there is, then you send an update here to say, here's a new block, or prepare a new block rather, and then refresh the window. So that's in here. And it's also called by the block logic. So whenever the user moves the block, there is a check whether the block can be actually moved. If it can, then it's moved. So that's the move down. And if it cannot, then it calls the update method to say, hey, I need a new block because this one is stuck. And then in the update, I check whether the new block can be placed. If it can, then the game carries on. If it cannot, then the game is over. And this is how I detect the game is complete. And that's it. Yep. So the actual code is on GitHub here. I've got the link in the presentation, and I will send the slides. So it's all available in here for you to have a look and hopefully play it a little bit. Thank you.
Wow. That's awesome. You should definitely scroll through the chat, Pierre. We got some questions and feedback in there. But that's really impressive. What did you make that typeface, or where did it come from?
You mean the font? No, it comes
Yes.
from it's a free font. Forgot the name.
Well, it looks really good.
Here, yeah, it looks. It's like old-fashioned, but it's actually here.
Yeah, it's the
am I
usual
still sharing my screen?
Monospace.
Did you ask, are you still sharing your screen, or?
Yeah.
I no longer see it.
Okay.
I guess Zoom bombing exists everywhere, huh? Well, at least it stopped, I suppose.
Just looking at the chat. Yeah, for the version, I actually looked at the runtime debug package, but I don't know. I couldn't figure out how to get the actual version of the current module and the commit ID. It was more about the modules that it uses, which was not useful to me. So yeah, I did it that way. I actually asked on Golang Nets to see if there was already something that someone did, or if I was missing something. Didn't get any really real answer. I just got an example of a shell script to do that, so I decided to do it in the package and just run it whenever I need to.
Yeah, for my project, I embed it at link time with compiler flags, passing it in from the outside. I don't know of a way to fetch it at runtime that doesn't require some kind of special build.
I got kicked.
Yep, we have somebody messing with us. Someone joined and started kicking people out.
Should make it password protected next time.
Yep, I've been, trying to avoid overcomplicating things because we hadn't had a problem here, but
yeah.
Egon, I see you changing lobby settings, and I think that's probably a good idea if you want to leave that turned on.
Yeah, I was kind of looking around, but there's.
I haven't needed these more advanced controls before, so I didn't know how to do that. But if a lobby is a thing that asks us whether someone should be allowed to join the call, then I think that's exactly what we want. Okay, well, I'm sorry for the chaos there. But at least pretty much everyone seems to have been able to come back, and fellow Jitster is no longer here, so success. All right, so we were talking about fetching versions at runtime. I don't know if there was anything else we wanted to say there.
No, I just wanted to know if he's tried it, because I haven't myself, and I expected that it wouldn't work for the main module, but it may have worked.
Yeah.
I think it works only if you go install with a specific version. So if you do go install the project that the latest, then it will attach it.
I see. Yeah, I definitely didn't try that.
Okay, well, great work. I feel I haven't done any custom keyboard shortcuts stuff. And I mean, I was just impressed that you'd already gotten there. It's a lot more polished than I guess I was expecting. It looked fantastic, and I can't wait to try it.
Thanks.
Okay. Any other questions? All right. Well, I am going to stop the recording. So thank you, everybody, for coming to this month's community call.